So let's do a quick summary of what we just did in that last problem in the word cheese. If all 6 letters were different, to find the number of ways of arranging the letters would simply be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, would give us 720 ways of arranging the word cheese. However, because the e's are the same, we are overcounting with that 720. So we actually need to divide the fact that there are 1, 2, 3 e's means we need to divide that 6 factorial by 3 factorial. Okay, so that's the method that we do. So Mississippi, in this case, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So what's the top? If we're going to do this by the same method, we're going to do a fraction. The top part is going to be what? I hope that you come up with 11 factorial. There are 11 letters. Now, the fact that there are some letters repeated means that we're going to end up putting something down in the bottom. All right, so we have, in this case, we have, how many i's do we have? 1, 2, 3, 4 i's. So here we had 3 e's and we got a 3 factorial. Now we have 1, 2, 3, 4 i's. So what are we going to divide by? Hopefully you got 4 factorial. Now that's not the only letter that's being repeated. We also have 1, 2, 3, 4 s's. So we're also going to divide, again, because all of those s's are not different letters, they're all the same letter. We're going to, again, we'll still have too many outcomes or arrangements if we consider all those s's to be different because they're the same. There's 1, 2, 3, 4 of them. We're going to need to divide by another 4 factorial. Anything else that we repeat in there? The p's. There are 2 p's. So I hope that you can figure out by now that what we're going to divide by over here is 2 factorial. Okay. All right, now some people struggle with this in your calculator. You might want to do this in 2 separate steps. Do 11 times 10 times 9 times 8. There actually is a factorial button on your calculator. In my classroom, the calculators that I have, there's a couple of different kinds. The smaller one, the Casio FX260 Solar, has the factorial button actually right above the number 3. So I'm actually going to have to, I type in 11, and then I press the shift button and the number 3, and that gives me a very large number, which is 3,000, or actually not 3,000, let's say I don't even know what it is yet, 399,168,00. I actually read it better once I put some commas in there. That's 39,916,800. Okay, on the other calculator, the FX300MS, the factorial button is actually near the top left, right under the shift button. So I will type in 11, hit shift, and then hit the button right below the shift. And again, that should give me 39,916,800. All right, I'm going to do that same with the 4 factorial. And I get 24. 4 factorial is again 24, and 2 factorial is 2 times 1, which is 2. So maybe I should, in this particular case, divide by multiply these bottom parts first. 24 times 24 times 2, and that gives me 1152. So now again I have 39,916,800 divided by 1,152. All right, so now I throw that into my calculator, 39,916,800 divided by 1152, and that gives me 34,650 ways of writing the word Mississippi. All right, before we go on to the next problem, I'm going to give you one quick one that I want you to try out on your own. And then I want you actually to write out all the different arrangements. So I'm going to take the word Adam, A-D-A-M. Can you guys do that one on your own? Figure out how many ways there are of arranging the word Adam using the technique we just did, and then write them all out and see what you get. And then when you're done with that, we'll come back to and do number 14 together. All right, I hope that you were able to find that there were 12 different ways of writing atom. It's 4 factorial because there's 4 letters, but the A's are repeated, so it's 4 factorial divided by 2 factorial, which is 24 divided by 2, which is 12. Okay, for number 14, we now have 12 students that we're going to choose from. We're going to try to find groups of 5. And then just like the letter E in cheese, those groups of 5, the group of 5 students are actually interchangeable. So that makes this problem very similar to the ones we did with the letters. So in other words, if we have 12 students to choose from, we're groups of 5, so we have basically 5 different choices. So we line up 1, 2, 3, 4, 5. All right, so for the first choice, there's 12 students to choose from, so we'll choose one of those, 12. Now we've used up one of those 12, then we have 11, then 10, then 9, and the last spot we have 8. This is not 12 factorial because we only go all the way down 12 times 11 times 10 times 9 times 8. Now, but we did say here, and I'm going to draw a solid line here now, we did say that those 5 people could be used interchangeably. This is a group of 5. We don't care about their order. They're all interchangeable. And so of that 5, just like we had 3 letters in the word cheese, we got cheese factorial. We've got 5 people in a group of 5. We are going to put that over 5 factorial. All right, those are interchangeable people, and so otherwise we would way overcount the amount of the groups of 5 that we would make. So we end up getting 12 times 11 times 10 times 9 times 8, which is 95,040. And we divide that by 5 factorial, which is 5 times 4 times 3 times 2 times 1, or simply the 5 factorial. Let's see, divide that by, I'm going to put parentheses, 5 factorial and parentheses, and I get 792 when I divide that. All right, I use parentheses, so I'm making sure I'm dividing by this whole denominator here. 95,040 divided by 5 factorial gives me 792 different groups that I could make. Okay, given what we just did on number 14, choosing a group of 5 students from 12 to choose from, see if you guys can do, and get some help from the people next to you if you need it, if you guys can do number 15 on your own to see if you can figure out this time we have a group, we're going to make a group of 3 flags. We don't care about the order of them, and we're going to choose from 8 flags to choose from. So I'm going to stop it here, and then please bring it back up after you're done. All right, I'm going to choose 3 very quickly. I've got 3 spots, 8 choices for the first one, 7 choices for the second one, and 6 choices. 8 times 7 times 6. However, there are 3 flags. We don't care about the order of them, so we treat them all the same like the 3 E's. We're going to divide by 3 factorial, which is 3 times 2, which is 6. So I have 8 times 7 times 6 over 3 factorial is 6. I can actually cancel out these 2 6's here to save myself a little work. I've got 8 times 7, and I end up with 56 groups of 3 flags to choose from. All right. We can please stop and have a discussion if we need to try to figure some of this out. When you're ready to go on, then we will move on. Okay. This one, 16, is quite a bit different, or not quite a bit different, is a little bit different from number 14, because this one says if you have 12 students to choose from, how many different arrangements of 5 students could you make? All right, we still have 12 times 11 times 10. Again, we have five choices we're going to make. We've got times 9 times 8. Oops, I should be putting these up here, these multiplications. I'm going to erase those down here. Okay, and we still have those choices, but this time these are arrangements of 5 students. So we're just arranging them, which means like the order of them does matter, which means I'm not treating those 5 students like they're all the same, because which one is where makes a difference. So I don't need to divide by any repeated students there. So this is going to be simply 12 times 11 times 9 times 8. I look back at number 14, which was very similar, except I was dividing by 5 factorial. This one I had to divide by that because they were groups of 5 and the order of the students didn't matter. But now the order matters, so I don't need to treat the 5 students differently. And so I simply multiply those out, and I get, just like I got up here, 95,040 arrangements of students, different arrangements of students to choose from. Okay, all right, so see if number 15 and 17 are very similar. See if you can figure out now what to do, what's different about 15 and 17. These are arrangements of flags, which means the first, the second, and the third flag are different in terms of how we arrange them. See if you can figure that out, stop this, and then come back when you think you have it. All right, I've got 3 flags I'm going to choose, 8 choices for the first one, 7 choices for the second one, and 6 choices for the third one. They are not 3 identical flags. I don't treat the 3 of them the same. They are actually different arrangements. So the first one, the second one, and the third one makes a difference. I multiply those up, 8 times 7 times 6, and I get 336 arrangements of 3 flags. Okay. All right, let's see how well you guys can go ahead and at your table groups and answer the rest of the questions together, and then I'll have you come back and check this video when you're done. All right, so doing here's the solutions here. Let's talk about the different answers here. For 18, for the ice cream, because the order of the scoops matter, we're not going to be dividing by anything because each of those scoops are considered different, and so it's like a group of different scoops. In number 19, those handshakes is still one handshake. It's basically a group of 2 people, and it doesn't matter the order if Bob's giving Joe the handshake or Joe's giving Bob, so we consider those 2 people the same. Just like the 2 letters of or letters of cheese, those 3 E's are the same. So that's going to be dividing by 2 factorial. With number 20, in this particular case, they're coming as a group. We don't care if Bob, George, and Fred, what order they come in is all the same thing. So we are going to divide by 3 factorial again because we're going to treat those 3 people the same. So we basically that's when we do have the division. However, in 21, they're each going to different classes, so it does matter who's going to which one. So we aren't going to treat those 3 people the same, and we're not going to divide by anything. For number 22, those 6 players are interchangeable. They're just my starting squad. So because they're interchangeable, just like the letter E was interchangeable with cheese, we're going to divide by that 6 factorial to get the number of starting squads. And combinations of 2 colors, again, those 2 colors, we don't care if it's blue and then black or then black and then blue. Those would be a terrible color combination. But either way, the order doesn't matter, and those we treat them both the same. So we are going to divide by 2 factorial. So here's the homework at the bottom. And I want you to make sure that you have those problems done before class on our next class.